So good evening, everyone, and welcome to the interview preparation session, ongoing interview preparation session. So yesterday we saw some of the basic data science questions. So now we'll be diving a little deeper and we'll be going through data science algorithms. So let us take the first question of the day. So first question is what what are the different learning methods used in ML? Okay, you can put your chat, your answers in the chat. I'll be checking that. Yeah, correct, Sriniti. Yeah, they are supervised, unsupervised. Actually, we have three: supervised, unsupervised, and last is reinforcement learning. Okay, so supervised learning, unsupervised learning, and reinforcement learning. So next question. What are the difference between these three? What what is the difference between the learning methods? So we have supervised, unsupervised, and reinforcement learning. Okay, so first we'll see the difference is this supervised learning. It learns, how does it learn? Okay, so it learns using labeled data. Okay, second one, it learns without using any labeled data. Okay, unsupervised, no, without using any labeled data. Yeah, schemas, yeah, you can say schemas are also different. Also, in reinforcement learning have agents which are put inside an environment, and they just work themselves. So they are given a goal. Okay, they have to reach that goal, and on the way they are given rewards or punishment according to their actions taken on in that environment. So that way they learn. So if suppose the learner does a right job, he will be rewarded for it. If otherwise, if he doesn't do the right, like if he doesn't take the right path, he will be punished. So that is known as reinforcement learning. So you can say a learner interacts with environment. Okay. What the size also. Okay. So next, what kind of data you use? So here supervised we use labeled. Here in unsupervised we use unlabeled data, and here no data is present. It is just an interaction of a learner with its environment. Okay. Then what type of problems can we solve using this? So using this, okay, then simple, not simple linear, it is supervised learning. We have classification and regression. Classification and regression. Here we have clustering, association. We have any more clustering? Yeah, I think these two. And for this reinforcement learning, what kind of you can say problem do we deal with? Is here we either deal with exploration or exploitation. Then okay, here supervision is required. You can say supervision required. Here no supervision required. Same thing for this also. Same as USA. Now, what are the algorithms we use? So all the classification and regression algorithm we can use here. Like we have linear regression, logistic regression, KNN, then the decision tree, random forest. Okay. First, the supervised, unsupervised, we are having hierarchical clustering or then k-means clustering, association rules. Okay. For reinforcement learning, we have Q learning and another SA or SA. Okay. Uh, Apart from that, if we talk about this supervised learning, okay, it can be so where is it used? If we search, so supervised machine learning can be used for risk evaluation. You can say risk evaluation. Then we also what else? Risk evaluation, sales forecast. Okay. Now for this unsupervised, if we talk about application, okay, anomaly detection, anomaly detection, and we can also use this in recommendation system. And apart from this, reinforcement learning has some interesting applications. Okay, so reinforcement learning can be used in gaming industry, gaming or creating games. Also, self-driving cars, uh, also healthcare. Okay, so these are the applications. So coming to the next question. Coming to the next one. What is supervised learning? And the types also we need to find it. Types of supervised learning. Okay. Okay. What is anomaly detection? Anomaly detection is like you can say a rare event. It is a rare event which differs from majority of the data. You can say is an anomaly. Like suppose, what can we give example for that? Suppose you can say launch sale of a phone. Suppose, yeah. So that day the sale will be increased heavily. But if we go according to the general sale, you'll see that that day will stand out. Or you can say if we see that will be like an outlier. But statistically, it will look as an outlier, but it is not actually, because that day a major sale has happened. So that sale will be known as an anomaly in the, you can say, data. Yeah, Srinti, why is known classification and regression. Yeah, correct. So supervised learning, we have label data in which we know the input and output. Okay. And here, yeah, they are of two kinds, classification and regression. So coming to the next question, what is classification? Okay, let me tell you. So classification is a supervised learning problem in which the feature to be predicted, okay, the output, you can say, output contains categories of values, okay, and each of this category is considered as a class, hence the name classification. Okay. Now the thing is, each of this category, okay, so every predicted value should fall into each of this category. So our prediction, if suppose true false, like true false or pass fail, okay, these are our categories. So our prediction should fall into one of these categories in classification. So you can say classification is a supervised learning problem when the feature or the predicted output contains categories of values. Okay. Now, if we want to give some examples on that, we can say classification like KNN, we have SVM. SVM can be used for both. Naive Bayes, we have decision tree. Again, this can be used for both. Random forest, again, this can be used for both. We have logistic regression, which is classification. Okay. So coming to the next one, what is regression. Yeah, Venki, that new things means identify, predict the output using the training data is, yeah, we can say that. That is for supervised. Yeah, it is correct. But for classification, we are having discrete outputs, categorical outputs, basically. Yeah, likewise, please tell about regression. Okay, for classification, we had a discrete or you can say categorical output. In case of regression, okay, we predict a continuous output. Okay, so we can say regression analysis is a supervised machine learning algorithm in which we predict a continuous outcome or output variable. Okay, and this output variable is based on one or multiple you can say input or predictor variables. Okay, so another thing we can for regression we are just making a equation, we are forming an equation. So basically y is equals to, if we are having multiple variables, predictor variables, multiple input variables, we'll be taking the we'll be finding out the coefficients for each of the variables. Okay, for each of the x variables or input variables. So y is equals to, suppose beta 1 x1 plus beta 2 x2 plus beta 3 x3. We will be finding out all the beta values, and with that we can form the equation. Yeah, and examples, if we yeah, Venki, correct. Example, if we are going to give for this, examples will be like linear regression. Then we are having decision tree, support vector regression, lasso regression, ridge regression, random forest, and many more we are having. Okay, next coming to, so this we are done with supervised. Next coming to unsupervised. So what is unsupervised learning? And also, what are the types? Okay, so unsupervised learning, okay, we can say is a machine learning technique in which uh, okay, in which we discover patterns or uh, information, you can say, from data. We extract this patterns and information from data which was not previously detected. And this mainly we don't have a label data. Yeah, yeah, Venki, correct. Output is not known here. So we deal with unlabeled data here. And types are like clustering and association rules. Okay, two types. So next, what is clustering? Yes, Nitin. Output is unknown. Yeah, Lokesh. Anomaly detection is an application of unsupervised learning. It is not a algorithm. It is an application. Okay. Anomaly detection is an application of unsupervised learning. Yeah, identifying of homogeneous records. Okay. So coming to clustering, so we can say it is it is an algorithm which comes under unsupervised learning, and it mainly you can say deals with finding a pattern in a collection of uncategorized data or unlabeled data. Okay, so the main thing is unsupervised learning clustering algorithm will process the data and find out natural groups if they exist in the data. Okay, so we don't do any prior any changes in the data. So whatever groups can be formed inside the data naturally, we try to find that in clustering. Now, what are the types of clustering? So there are many types of clustering. Okay, just let us take that as the next question. Types of clustering. Yeah, hierarchical, non-hierarchical is correct. Okay, so let me tell you. So there are many different types of clustering techniques. We have been taught this agglomerative and exclusive, you can say, or partitioning. So let us go through them one by one. So first one is exclusive or partitioning. So in this clustering method, okay, data are grouped in such a way that one data can belong to to one cluster only. Okay, so here one data is belonging to only one cluster. Okay, this is known as exclusive or partitioning. And an example for this is k-means. Let me write it down. It is exclusive. Okay, and example is k-means. Okay, so the main thing to note here is a single data point belong. It will always belong to a single cluster. Okay, so that cluster may contain many points, but that one point should not belong to any other cluster. Okay, then second one we are having agglomerative. Yeah, for agglomerative, you know what is the example for agglomerative? We have been taught this hierarchical. Okay, so what happens in this technique? Okay, every data is a cluster first. Okay, and then we work iteratively to form to you can say join two clusters together to form a single cluster. Okay, then we are having overlapping. Okay, this is the third one, overlapping. Okay, in this, so we know this two, first two we know. So what is this overlapping? So in this technique, what we do, we form fuzzy sets, okay, to cluster data. So here what happens, each point or each data point, you can say, it may belong to two or more clusters. Okay, here uh, a single data point may belong to more than one cluster, but having separate degree of membership. Okay, so the weightage given to that member will be different for different clusters. Okay, so here some kind of value is given to a data point in a cluster. So that data point may be present in multiple clusters, but the weightage given to that point will be different. Apart from this, okay, so here example is uh, fuzzy C means. Okay, this is also a clustering algorithm. Then we are having probabilistic model or probabilistic clustering method. Just write probabilistic. Yeah, what is this probabilistic? So in this technique, uh, we use probability distribution to create clusters. Uh, so suppose we are having some keywords like man's shoe, woman's shoe, woman's glove, man's glove. If we are having these four, suppose, and we want to cluster it, okay. So these can be clustered into two categories, either shoe and glove, or also it can be clustered into man and woman, okay. So this way the cluster are formed, and it uses probability distribution. So these four are the major clustering techniques. Now coming to association rules. So what is association rules? Okay, so association rules allow us to establish associations amongst different data objects inside a large database. Okay, so we can say association rules is an unsupervised technique in which we discover interesting relation between variables in a large database. So example can be given like if a person in the morning is going to buy bread, he may also buy milk with it. Okay. So like the people, yeah, people who are buying a new home are most likely to buy new furniture along means after that market basket. Okay. Yeah, association. Yeah, these are you can say, yeah, these are related to association rules. Yeah, correct. Now coming to the last learning method. What is reinforcement learning? What are reinforcement learning? Yeah, so reinforcement learning, we can say, is defined as that machine learning technique in which we see how an agent, okay, how an agent reacts to its environment, or what actions does it take in an environment. Okay, we can say that about reinforcement learning. Okay, now coming to the next question. What are the types of reinforcement learning? What are the different types of reinforcement learning? Okay. So coming to this, it is of two types: positive and negative. Okay. So in positive reinforcement, the agent, the learning agent, okay, when it does a thing which is, you can say, which we want it to do, okay, so we give them a reward. So by that, the agent, you can say, is motivated to go for these kind of rewards. Uh, okay. Uh, so this is like a reward system. Okay. And we can say this type of reinforcement, it helps to maximize performance and you can say sustain change for a extended period of time. So here one thing to remember, we should not give too much reinforcement to a system or it may get over optimized. Okay. Then coming to negative reinforcement. So in negative reinforcement, if we want the learner not to do something and it does, we punish it. Okay. Instead of reward, here we use punishment or penalty, you can say. Okay. So we penalize the learning agent for doing a certain event. Okay. So this we want the learning agent to avoid such events in the future. So the learning agent learns from this and it tries to avoid this kind of event from occurring in the future. So you can say here we can say, yeah, so basically that only. So negative reinforcement, we can say uh, it in this method we penalize the agent for doing something, some event that should have been avoided, so that it learns from this behavior and in the future it tries to avoid this situation. Now coming to next one. Yeah, coming to next one. Okay, now let us discuss something related to statistics. Okay, so this is just the basic introduction to algorithms. So tomorrow we'll be going through some uh, more deep questions in algorithms, but here let us go to statistics now. Okay, so let us start with what is central limit theorem. What is central limit theorem? Okay. So what is central limit theorem? Let me tell you. So central limit theorem is a theorem that states that the distribution of a sample from a population, okay, a distribution of a sample from a population comprising of a large sample size. Okay, this large sample size may be defined as more than 30. Okay, so if it is having a sample size of more than 30, it is said that it will have its mean normally distributed, or you can say it will have a normal distribution. Okay, even if the population is not having quite a normal distribution. So here we can use the central limit theorem to do many calculations and also do hypothesis testing. Okay, we can calculate the confidence intervals. We calculate various, you know, that z statistics. We can calculate using this. So next question. Next question is, what is the assumption for normality? What is the assumption for normality? This is regarding a sample, okay? Sample, a population sample. So regarding a population sample, what is the assumption of normality? Okay, so the assumption of normality, it says that the mean distribution across a sample, okay, the mean distribution across a sample is normal. Okay, and we can say this is also true for uh, all the samples, all the independent samples. Okay, now coming to the next one, what is hypothesis testing? What is hypothesis testing? Okay, so yeah, so hypothesis testing, we can say in statistics, is used to see if a certain uh, experiment is true or not. Okay, so we can see here, so we make a statistical statement, okay, and we see if the statistical statement is significant or not. Okay, so in this, first we describe a null hypothesis or a hypothesis, you can say, that we decide. So the first hypothesis is the hypothesis that we intend to find out. Okay. And we mention that, and then we calculate a p-value. Okay. This p-value we calculate, and then we also calculate another value which is called as significance, which is also known as the alpha value. Okay. We calculate this and then compare this p-value with alpha. Okay. Okay, before that we also give an alternate hypothesis which is just the opposite of the null hypothesis. Okay. And then we find the p-value. If it is less than this alpha value, then the null hypothesis is rejected. Okay. And if the p-value is greater than alpha value, this null hypothesis is accepted. So we can say that if the null value is null hypothesis is rejected, we can say that the result obtained are statistically significant if null hypothesis is being rejected. Okay. So yeah, so friends, we will stop here for today. Okay. And for tomorrow we'll continue with the statistics, followed by some more questions on this, we can say, data science algorithms. Okay. Yeah. So friends, yeah, thank you and have a good day. Bye.